Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a topic in chemistry, and that is the concept of molarity. And this concept of molarity stems from the fact that when we are doing a chemical reaction, we need to know the amount or the concentration of the reactants and the products. So in this case, the concept of quantifying the reactants and the product is very important, because it's from this that we can know the amount of each of the species that is taking part in a chemical reaction which has been used. So in that case, I'd like to invite us to the discussion so that we can learn about this concept of molarity. So without further ado, thank you and welcome. So as I've said, the concept of molarity comes from the fact that we need to know the amount or the quantity of the reacting and the species of the product. And this molarity is given as caps lock, that's it's given as uppercase M, capital M. And now from definition, basically molarity is the number of moles of a solid per liter of a solution. Now that we've discussed in one of our videos about the concept of a mole and the Avogadro's constant and the other additional information regarding the concept of the mole. Now, by definition, molarity is the number. So this is the number of moles of solutes per liter of solution. So there are two basic concepts, or maybe the conditions that we have been given here about the liter of a solution and then the number of moles. So basically molarity is the number of moles of a solute per liter of a solution, bearing in mind that we understand the concept between those two. So therefore, this can be given as an illustration or a formula which defines molarity that we have given as a ratio between those two. So therefore, we can define molarity as the moles of a solute over the volume of a solution. That is in liters. Of course, we have said for a molar solution, that's moles of solute per liter of a solution. Now we're going to use this or maybe just an example for illustration, and try to see how we can be able to define the mole that we have said given a particular quantity of a solution or the solute. How can we be able to find the number or the molarity? So this is a sample question. So it says, what is the molarity of a solution prepared by dissolving 40 grams? So I'm going just to capture the information that we've been given, and I just repeat in case of just clarity. So what is the molarity of a solution prepared by dissolving 40 grams of sodium hydroxide in a liter of a solution? 1 liter solution. So what is the molarity of a solution prepared by dissolving 40 grams of sodium hydroxide in a liter of a solution? So for us to find the number of moles, now that we said for the denominator is the number of moles that we require to find, for us to find the number of moles of sodium hydroxide that has been dissolved, the number of moles is given as the mass which have been dissolved. So number of moles is given as the mass that has been dissolved over the relative molecular mass. And now the relative molecular mass that we require to find is the relative molecular mass of sodium hydroxide. Now for our information, this is 23. The molecular mass for sodium is 23, this is 16 for oxygen, and this is for hydrogen, it's 1. So the relative molecular mass is the sum of these masses of each individual atom that is forming this compound. So we find it to be 40. So this is 40 grams basically. So this is 1 gram, 1 mole forms 40 grams. And we have been told that the solution has been prepared by dissolving 40 grams. So for us to find the number of moles, let's call it N. N therefore implies this mass which has been dissolved 40 grams all over the relative molecular mass, which is 40 grams per mole. So therefore, we'll find that this is 1 mole. So as we defined the molarity, we said it's the number of moles of a solid over the volume of a solution. Now that we have 1 mole over 1 liter of a solution per mole, therefore we will have this solution of sodium hydroxide which has been prepared as 1 molar sodium hydroxide. So that's how we define the concept of molarity, or the concentration for this case in the sample question that we have been given. We can as well look for a second, try to look at a second example to assist us understand this concept of molarity. Maybe just grab that and just repeat it here. Right. So let's look at sample question 2. Try to see, of course I'll read it for our clarity and try to extract the information that is there for us to use for illustration. So question 2 states that molarity of a solution prepared by dissolving 25 grams. So we have 25 grams of sodium hydroxide. No, this is sodium chloride. 25 grams of sodium chloride was dissolved in 250 centimeter cube of a solution. So the number of moles of solid per solution gives us the concept of molarity. So the relative molecular mass, or relative formula mass for sodium chloride is 23 plus that one for chlorine is 35.5. So the relative formula mass for this is 58.5 grams. So this is the relative formula mass for sodium chloride, which means this one consists, this 1 grams in a liter of a solution has what we call 1 mole. So in this case, it is 25 grams that were dissolved in 250. So in this case, we have this one as 1 mole. Therefore, we can find the fraction or the ratio between this one and 1 mole and try to see how many number of moles were dissolved. So if 25 grams were dissolved and there is 58.5 grams per mole, therefore the number of moles that were dissolved equals to 0.427 moles. So if these are the number of moles that were dissolved, therefore we can say that 0.427 moles were dissolved in 250 centimeter cube. So for us to find the molar, or the concentration of that solution in terms of a molar, we're going to compare it with a liter of a solution. So whichever number of moles that are found in a liter of a solution, then that one forms the concentration of that solution given in molarity. So we shall have 0.427 times 1000 divided by 250. So this one goes here 4 times. So we shall have 1.7 molar. That's the number of moles of a sodium chloride per liter of a solution. So the concentration is given as 0.7 molar solution of sodium chloride. So basically that's how we're going to find the molarity of these different types of solutions, given those sample questions. Now there are others that are going to involve, of course, different volumes, or maybe different number of moles for one to be required to find the number of moles or the solution that is involved. So in this case, these 2 examples, of course, assist us illustrate the concept of molarity and how we can be able to use the relative molecular mass or relative formula mass in comparing it with the information that we have been given for us to attain the concentration of the solution. So for that case, I hope that we have understood those two concepts. We're going to apply them appropriately in case of need. So for that case, that is it for today. Thank you. Bye. God bless.